rational exponents. We're going to be working with exponents that are fractions. And when you have an exponent that's a fraction, that means something special. Okay, let's start out with, hold on, let me get, all right. Let's say I had, now here are some examples with rational exponents. We'll just do down here and say we have x to the 1/5. And why not, let's do 4 to the 3/2. All right. Now, rational exponents, I'm going to come over here in the corner. An exponent that is a fraction is a fraction means you have, whoops, hold on, a root. So it'll be, it'll be a square root, cubed root, fourth root, fifth root, whatever. Now, 9 to the 1/2 power means a square root of 9. The bottom tells you the actual root you'll be using. A 2 means a square root. Then you simplify the square root. 25 to the 1/2 power means you have the square root of 25. It's a 2 in the bottom. That means it's a square root, and then you simplify that. 8 to the 1/3 means you have a cubed root. Again, the bottom tells us the root. Now we can simplify 8. I can simplify the cubed root of 8, which is just 2. Here, x to the 1/5 means the 5th root of x. Now this one's a little different. It's got a 2 in the bottom, so it's a square root of 4. So the 2 represents the square root. The 3 in the top means this. Let me change that to a different color. We'll do green. Means you do this. The bottom is the square root. You take the square root, and then whatever that top is, I'll put that, highlight that in 3. And whatever the top is, you raise your answer to that power. That's a little different, but you always do what's in the bottom first. Now, I want to practice right quick going back and forth. Let's say I had a square root of 7xy, and I said to change that into a rational exponent. You would put the 7xy in parentheses. Since it's a square root, square roots are represented by 1/2. Let's say I had the 11th root of, I don't know, 7x squared y cubed. I put the 7x squared y cubed in the parentheses. And on the outside, my exponent will be 1/11. So, we want to be able to go back, we want to be able to change a root symbol. So make sure you understand this. That's an 11, so the bottom is an 11. Whatever the root is, that's what goes in the bottom of your fraction of the exponent. So we want to be able to go back and forth. So if I gave you, if I said let's take 13 xyz raised to the 7/13th power. Remember, that's the root symbol. So we would put a 13th root. Underneath, I would put the 13, the x, y, the z. And that top number tells me to do this. Put the whole thing in parentheses and put that number on the outside as my exponent. Now, there's not anything else I can do with that. That's all I can do. But we just need to be able to go back and forth. If I had the square root of x to the 9th, y to the 13th, and I said change that to a rational exponent, since it's a square root, we're going to put 1/2 as the exponent. Alright, now I want to show you how to simplify things. Let's say inside a set of parentheses I had an x to the 4th, a y to the 8th, and that's to the 1/2 power. And your instruction says to simplify. Simplify means turn it back into a square root and then simplify like we've done in the past. Whoops, I got the backwards one. Y to the 8th. And this is where we divide the exponent inside the parentheses by the index. So this and this mean the same thing. I've divided the exponents by 2 because it's a 1/2, and that's a square root. Let's say I had 27 x to the 9th, y to the 21st power, and I'm raising that to the 1/3. Now, to simplify it, the easiest way to do it is to convert it to a cubed root. And then simplify it like we've done in the past. That's a cubed root of 27. So the cubed root of 27 is 3. Then we divide the exponents by 3, and we'll get this. So this is the final answer. There is a problem like this on the final. Let me do another one. Let's say I had 144 x to the 12th, y squared, and I put a 1/2 here. That means square root of 144 x to the 12th, y squared. Then we simplify it like normal. Square root of 144 is 12. Divide the exponents by 2. So if you see this on the test, which you will see, you put it under the root symbol, then simplify it like we've done in the past. Now, we're also going to have to use the rules for exponents on when we're multiplying. Well, let's change that to a 7. Let's change that to a 7. When we're multiplying variables, we're going to use the same rules for adding exponents. Now they're just going to be fractions. So 1/7 plus 2/7 is 3/7. That's the answer. You don't do anything else. Let's say I had x to the 3/4 divided by x to the 1/4. Well, what's the rule for dividing? It's subtracting. So it's going to be 3/4 minus 1/4, which is going to be x to the 2/4 power, but then you simplify your exponents if you can. So that's going to give me x to the 1/2. So you're doing the same rules. Add the fractions or subtract the fractions. Now you know the only way you can add and subtract fractions is if you have a common denominator. Now, these do not have common denominators. Now, I'm going to show you a shortcut on how to add fractions. You've probably seen it. I may have shown you before. But there's a little shortcut you can do. You can multiply the bottoms together, and that will give you the common denominator. To figure out what goes in the top, you cross multiply and put whatever you get in the top. And then we'll get 31 over 35. So this turns out to be x to the 31 over 35th power. I'm going to do this a few more times just so you can see. Let's say I had, I don't know, we'll do x to the 9/11 times x to the 5/8 power. Alright, so let's come over here. We're adding fractions with different denominators. So the first thing we do is multiply the bottom numbers. Oops. We'll get 80. We'll get 88. Cross multiply to get what goes in the top. So 9 times 8 is 72. 5 times 11 is 55. 72 plus 55 is 127 over 88. That's the final answer. If you're subtracting, then you still got to get a common denominator. Let's say I had x to the 10/3 over x to the 5/9. Well, you know the rule says to subtract. So I'm going to do this. We're going to multiply the bottoms together. So I'm going to get 27 in the bottom. Oops, change that to red. 27 in the bottom. Cross multiply. 10 times 9 is 90. 3 times -5 is -15. Keep going. That's going to give me 75 over 27. Now, you always try to simplify the exponent if you can. Notice both of these are divisible by 3. 75 divided by 3 is, let's see, 25. Duh. 25/9. This is the answer. X to the 25/9. Let me make that x a little bit bigger. It looks kind of weird. X to the 25/9. There we go. Now suppose I had this. Let's just say I was doing a fraction. Let's say I had x to the 1/3 over x to the 5/6 power. Going to be subtracting. Now let's just find the common denominator doing what I did earlier. Let's just find the fractions. So multiply those two together. We're going to get 18. Cross multiply to get what goes in the top. Minus 15. Keep simplifying. 6 minus 15 is -9 over 18. I can simplify that a little bit more. That's -1/2. Now pay attention. That's a negative exponent. What do we do with negative exponents? We have to convert it into a fraction and make the exponent positive. So you will see negative exponents when you're doing this stuff. The rules all apply. You're multiplying. I mean, you're adding or subtracting, or you're multiplying. Here's one where you have to multiply. Let's say sorry, my dogs are barking. Let's say I had x to the third. Whoops, let's change that into a, let's say I had, I don't know, we'll do x to the 1/5. Whoops. Y to the 2/3. And on the outside I had a 1/4. The rule says multiply the exponents. 1/4 times 1/5 is 1/20. 2/3 times 1/4 is 2/12. Then if we can simplify, we simplify. I can simplify 2/12, it's just 1/6. This is the final answer. So you're doing the same rules. Okay, same rules.